I hope you have seen my previous video on what is BERT. In this video, I explain how BERT works, the fundamentals of it. In today's video, we are going to do email classification, whether it's a spam or non-spam using BERT. Now, BERT will convert an email sentence, the whole email, into an embedding vector. So we saw in a previous video that the purpose of BERT is to generate is embedding vector for the entire sentence, and that is something that we can feed into our neural network and do the training. So here we will generate a vector of 768 length. Why 768? We have covered that in a previous video. And then we will supply that to a very simple neural network with only one dense layer, one neuron in the dense layer as an output. We'll also put a dropout layer in between just to tackle the overfitting. Now, if you open this BERT box, by the way, it has two components, pre-processing and encoding. And we talked about that in a previous video as well. So previous video, watching that is quite a prerequisite. So let's jump into coding now. Now here I have downloaded this file from Kaggle, simple 2 columns, category ham or spam, and here is the content of your email. I have imported few basic libraries here in my Jupyter notebook, and I'm going to simply read this CSV file into my pandas data frame, which looks like that, and then I will do some basic analysis. I will do df group by, let's say, category. So here I have 4825 ham emails and 747 spam emails. You can clearly see there is some imbalance in our data set. The question is, how do you take care of imbalance in your data set? Go to YouTube, search for Code Basics Imbalance Dataset, and you will find my video where I have outlined 3 different techniques for handling imbalanced data. There is a notebook. I think you should watch the video so you get an idea. I'm going to use a technique called downsampling, and what that means is it's pretty simple actually. Here, if you look at the value counts, actually I should be doing this. And if you check the percentage distribution, you will see that you'll see that 15% are spam emails and 85% are ham emails. So there is definitely an imbalance. So the downsampling technique, what it says is, from 4825 ham emails, just pick any random 747 samples, discard a rest of them. That way, then you have equal number of spam and ham email. Now, obviously, when you're discarding rest of the samples, you are losing your training data, which in certain cases might not be good. But for our tutorial, just to keep things simple, I will go with that approach. There are other approaches such as smooth oversampling, basically oversampling the minority class, etc. So you can watch the other video and you can try some other approaches, but I'll just go with a simple approach. Here I will create a new data frame called df spam, where I would say df category is equal to spam. Okay, and let's print a shape. Obviously the shape, this is what you would have expected, and I will do the same thing for ham. So I'm creating a separate data frame for ham and spam email. This data frame has only spam emails. This data frame has only ham emails. And now I need to sample this ham data frame. And the way you do that is by doing sample. So if I do, like, say, sample 2, it will only return me 2 samples. I want to sample 747 records. And the way you do that is, of course, you can type in 747, but in order to keep the code in a good condition, I will just do this. So shape 0 will return 747, and that I will call downsampled, and I'll just print the shape just to make sure. See, both are now 747. This is 747. This is 747. I would now concatenate both of these together to form my df balanced data frame. So I will call it df balanced data frame is equal to pandas pd.concat. So concat is the function, and in here you can supply both your spam and ham data frame. I think that should work. And now when I do value count for this guy, the value count is still a problem. Let's see. Oh yeah, I think I made a mistake here. I should have done this. Okay. All right, now I have equal number of spam and ham emails. I discarded rest of the sample. I just picked 747 samples for ham category, discarded rest of it. Again, that might not be considered good because you're losing valuable training data set. But the goal of this tutorial is to explain you BERT, and that's why I'm just keeping the thing simple. For other approaches like SMOT, etc., you can watch my other video. And in the balanced data frame, if you want to print few samples, you can print just to make sure things are good. Now I would create a new column called spam, because here it's a text column. I want to create a binary column called spam, boolean, like 1 or 0, that kind of thing. And you know how to create a new column. When you do this, it will create a new column. And the way you create a new column is you go through the existing data frame, the category column, and you use the function apply. So if you've seen my pandas videos, you will get an understanding that on category column, we are applying some transformation, and that transformation here you can define any Python function, okay? But here, since this is a simple function, I will just use lambda. Lambda is a quick way of writing a function, and I will say, okay, if my x, what is x? Each of the values in this column category. Let's say if x is spam, then the value is 1, else 0. This is the correct syntax. You're saying 1 if x is spam, otherwise 0. I would again sample it just to make sure my new column is created properly. Invalid syntax. If yes, should be this. Perfect. Whatever. Okay, now I have my data frame ready. I'm ready to do train test split. And we have seen this again and again in so many of my machine learning videos. We use train test split from sklearn, and this is a standard way of doing it. You will use stratify so that in your train and test sample, the distribution of the categories is equal. All right, my X train, etc. is ready. I will just print the head of X train just to make sure. Great. Now comes BERT, the most important part. All right. So BERT, in our previous video, we have seen how can you create the pre-process and encoder model encoder object. And I'm just going to copy paste because we have covered this in our previous video. Just to summarize, on TensorFlow Hub website, these trained models are already available. So you're just using this URL to download those trained models. And you'll realize that when you execute this, you'll see star for a few seconds or minutes based on your speed, because it is downloading the trained model locally on your computer. Now, as you have seen in our presentation, that my goal is to supply sentence to BERT model and create this length vector. Let's write a simple Python function that takes the sentence as an input and returns this vector as an output. Meanwhile, this download got completed, so my BERT preprocess and encoder is ready. I want to write a function, something like this. When I say get sentence embedding, and when I supply a sentence like this, it should just return me 768 length vector. Now, to make this function more versatile, we can take an array. Okay, so we can supply basically multiple statements. So that will return, multiple 768 vectors. So here, I'm just putting any random statements, you can put whatever you want. And the goal is to write this particular function. Now, if you have seen my previous video, I would ask you to write this yourself without relying on me. A good student would pause this video and write the function themselves. All right, considering that you have attempted, now I will write this function. It's pretty simple actually. You are getting sentences as an input and you call preprocess first, correct? You call preprocess on your sentences, obviously, and you get the, actually there is a spelling mistake. So you call preprocess on sentences, you get preprocess text as an output, and that you supply into BERT encoder. The code is so simple, friends. It's just like a function pointer, it's a simple function. So you are doing pre-processing first, and then you are doing the actual encoding. Now, the encoder will return a dictionary, but from that dictionary, you need to choose a pooled output. We have talked about that in our previous videos. So again, if you have not seen previous video, you will have some difficulty understanding this particular video. That's why watching previous video is very much essential. I'm just going to return this, by the way, and that would be my sentence encoding. And when you run it, you can say it's returning a tensor of shape 2768. So this particular tensor is my sentence and encoding for the first sentence. For the second sentence, here is my encoding, and this encodings are returned by pre-trained BERT model, which I have downloaded from TF Hub website. Great. Now let me call sentence encoding for some simple words, like banana, grapes, mangoes, and so on. I want to see what this really means. What is the benefit of having these BERT encoding? So I will try cosine similarity. Cosine similarity is a way to measure how similar two vectors are. If two vectors are pointing in the same direction, then that means the cosine similarity will be close to 1. Now, if you don't know about cosine similarity, you can do Code Basics cosine similarity. You'll find a very simple video I try to make videos which even a high school student can understand it easily. And here I have explained that if you have vectors like this where the angle is more, then the similarity is less. But if you have vectors where the angle is less, then they're more similar. Okay, so that's pretty much about it. So cosine similarity I will call now. So this E, by the way, let me print E. E is the embedding of all these words: banana, grapes, mangoes, and so on. I got 6 embedding. Each embedding is a vector of size 768. You would now think that the first 3 vectors would be similar, their cosine similarity. They would be similar in terms of cosine similarity, and these 3 would be similar because these 3 are fruits, these 3 are not fruits. Obviously, you know that they are entrepreneurs. So here I would say embedding 0 and embedding 1. Now this expects 2-dimensional list. That's why I'm just putting 2-dimensional list here. See, banana and grapes are very similar. But if you do banana and Jeff Bezos, let's do that. So by the way, 0.99 close, if value is close to 1, it's similar. 3 is not that similar. I know it's 0.84. So it's the similarity is not like it will capture you need to understand how these embeddings are calculated. They're calculated based on the training that they did on Wikipedia and Google Books, where based on the context. So based on the context, as such, profit and loss will also be similar. So you need to understand that, okay, it's not a silver bullet here. But if you do like 3 and 4, 3 is Jeff Bezos, 4 is Elon Musk. See, 98%. Because when they trained BERT model on all the Wikipedia text, the context in which Jeff Bezos and Elon Musk appear would be similar. When they would be talking about Jeff Bezos, you will see words such as entrepreneur, rich, like company name, their plans, and so on. So that's why their cosine similarity is similar. Anyway, you can play with it, but let's get back to our main objective, which is to build the classification model. So now we have this function which is returning the sentence vector, but I mean, we are not going to use this function. We will be using these two pre-processing and encoding functions into our BERT layer. Now I'm going to create a model. So there are 2 ways of creating the TensorFlow model. One is sequential and one is functional. I would suggest you read this article regarding sequential and functional model. In our videos so far, we have created sequential models which look something like this. There is a sequence of layers, and you know how to create sequential model because that's what we have done so far. But functional model looks something like this. You create an input layer, then you create another layer and pass the first layer as if you're calling a function. See, as if you're calling a function, you're supplying this hidden layer as an argument of this function. And eventually we create a model. We say, okay, inputs is this and outputs is this. So output would be this and input is whatever you created. The benefit of this is that here you can have basically non-sequential type of architecture where you can have 2 inputs, 2 outputs. You can build complex models out of this. So we are going to use that approach. So let's first create our input layer. What is our input layer? So in input layer, I will say shape is this. So I will let it derive based on what encoding BERT is passing. And then the data type would be tf.string. And this is the name of the layer. You can give any layer. And this is my input. Again, if you read that article, you'll get an idea. I created input layer. Now, that input layer, I will pass it to BERT preprocess. What is BERT preprocess? We have seen it here. This is BERT preprocess and this is BERT encoder. So I'm passing that as a text input. What I get is a preprocessed text, and that I supply it to BERT encoder. Okay, this is fairly straightforward, and you get outputs as a result. So these are BERT layers, basically BERT layers. Now I will create neural network layers. So in neural network, I will create a dropout layer because dropout helps with overfitting, etc. So I'll create a dropout layer. I'll say, okay, maybe 0.1% of neurons just drop. I had made a separate video on dropout as well, so you need to go through that video. So this is dropout. And since it is a functional style neural network, you call it as if this is a function and you need to supply an input. Now, what is the input? Input is output's pooled model. Because remember, the pooled pooled output will have your BERT encoding of 768 size vector. So that's my layer. I'll just call it L. And then second layer is dense. And this layer, by the way, has only one neuron because one neuron is telling you whether email is spam or not. And activation is sigmoid because sigmoid, if it is more than 0.5, it's spam, less than 0.5, not spam. Just give any output, any name. And again, this is a functional style. So here in the function argument, you will pass whatever you got from your previous layer. And I'll just call it a same variable. So now I got my neural network layers defined. I will construct a final model now. Construct a final model. How do you do that? Well, tf.keras.model inputs. So there are some inputs and there are some outputs. What is my input? Text input is my input. And what is my output? Well, L. Now see, this is an array. So if you want to have multiple output layer, multiple input layer, this architecture allows you that. We can use sequential here as well. We are not using multiple input output, but this is just for a demonstration. So here I got my model and I will just control enter. Okay. Just print a model summary to take a look. Here you see trainable parameters is 769 because 768 is my input. So if you look at our diagram here, so this layer will be of size 768. So you need to train those parameters and one parameter for this, so 769, and remaining parameters are non-trainable because they are coming from BERT and we don't need to worry about retraining them. Okay, now comes model compile, and we have pretty much used Adam as an optimizer, loss binary cross entropy because our output is binary 1 0. And in the matrix I will use a couple of them, including accuracy. I will use precision recall. By the way, when you supply matrix, it doesn't have impact on the actual training because the training is driven by loss function, but matrix is you're just printing this number so you get an idea on how your training is working basically. And you will do model.fit. I would just go with 10 epochs Training is a little slow, but you can see every iteration it is printing loss, accuracy, precision, and recall. It is just printing those metrics. The actual training is driven by this loss function. It took some time, but eventually my accuracy came out to be 91%. Precision and recall is this much. Now I made my dataset balanced so I can rely on accuracy, but in general, if you are training on imbalanced dataset, you should not rely on accuracy. Okay, and you can watch my other video. But when you do model evaluation, again, accuracy is coming to be 90%, which is okay. And then I called model.predict. And when you do model.predict, you get your y predicted, and y predicted is a two-dimensional array, but if you do flatten, it will become one-dimensional array. Okay, and then what I'm doing is, since y predicted is a bunch of sigmoid values, 0.5, 0.7, 0.8, what I'm saying is, if the value is greater than 0.5, put value 1, otherwise put value 0. And when I do that, my y predicted is a bunch of ones and zeros. And then I have my y test. So using y predicted and y test, I can plot a confusion matrix here. So this is the same matrix, but I plotted that in Seaborn so that it looks visually more appealing. So here, what this confusion matrix is telling you is that on the diagonal, you have your correct predictions. So this is truth on y-axis, x-axis is predicted. 154 times I had 0 as a truth and my model predicted that to be 0. 185 times I had a spam email and my model predicted it to be a spam email. And these are the errors. So on 2 occasions, what happened was I had a spam email, but my model says it is not spam. And 33 times the truth, basically my email was not spam, but it said it is spam. All right. When I print classification report, I see good accuracy, good precision, and good recall. So it's important that your F1 score is higher. So here in both the cases, the F1 score came out to be 90%. And when I do inference on couple of sentences, so see the first 3 look spammy and the values are, see, more than 0.5. More than 0.5 means it's spam. And for these two, they look like legit emails. So the value is less than 0.5. That's all I had for main tutorial. Now as an exercise, go to TensorFlow tutorial. Just type TensorFlow tutorial. And here in the text, there is a tutorial called classify text with BERT. So the exercise is actually rather simple. All you need to do is try out this Jupyter notebook. It's a ready-made Jupyter notebook, but I want you all to try this out, copy paste this code, try to tweak it and try to see how this is working. It is using some advanced APIs, text dataset from directory, etc., prefetch. We have covered all of that, TensorFlow dataset and all of that. And just try to understand this particular example. It is about movie reviews. BERT can be used for a variety of NLP tasks such as named entity recognition, sentence completion, and so on. In our video, we just kept things simple. But I hope you liked it. If you did, please give it a thumbs up and share it with your friends. And please try out this notebook. Thank you.